Problem 123 on page 18. A rectangular piece of wood 50 mm by 100 mm in cross-section is used as a compression block as shown in the figure. Determine the maximum axial force P that can be safely applied to the block if the compressive stress in the wood is limited to 20 meganewton per square meter and the shearing stress parallel to the grain is limited to 5 meganewton per square meter. The grain makes an angle of 20 degrees with the horizontal as shown. So if we are going to cut a section along the grain of the wood, and then we are going to draw the free body diagram. The free body diagram would look like this. So we have the external force P, and here we are going to have an internal force along the grain or parallel to the grain, and that will be the shear force, in another internal force that is perpendicular to the grain, and that is the normal force or the axial force. And so looking at the free body diagram, we can see that V and N are perpendicular to each other, so it's better if we are going to rotate the axis like this. So this will be our rotated x-axis and this will be our rotated y-axis, and then our external load P will be this one, and our normal force here, and the shear force here. So this is the shear force, the normal force, and the external load P. And if this is 20 degrees, that means this is also 20 degrees. So if we are going to sum up forces along X, we will have V and the X component of P, and then if we sum up forces along Y, we'll have N and the Y component of P. But let us first solve this area. So this is the projected area here. This is 50. This one, let's just call this L. And then from here, if this is 100, this is 20 degrees, this will be our L. And from cosine of 20, that's adjacent divided by the hypotenuse, that means L is 100 over cosine of 20, and that is 106.42 millimeters. That means our area is 50 times 106.42, that is 5,320.89 square millimeters. Okay, so for compressive stress, that is stress equals the normal force over the area. So the area is this one, which is 5,320.89 square millimeters. We are going to sum up forces along Y equals 0. That means N minus the Y component of P, which is P cosine of 20 equals 0. That means our N is P cosine of 20. Then we substitute that here, and we are given the compressive stress to be 20 meganewton per square meter or 20 megapascal. 20 equals N, that's P cosine 20 divided by the area of 5,320.89. We'll get the value of P considering compressive stress equals 113,000 247 newtons, or that's 113.25 kilo newtons. That is considering the compressive stress. Considering the shearing along the grain, shearing stress is V over A. To solve for B, we just sum up forces along X equals 0. That's V minus the X component of P, which is P sine of 20. So V therefore is P sine of 20. Then we're given the shearing stress. That's 5 meganewton per square meter, or 5 megapascal. So we substitute these values here, we get, and also our area is still 5,320. So we have 5 for the shearing stress equals V, which is P sine of 20, this one, divided by the area, which is this again, 5,320.89. And then we get a value of P considering shearing stress equals 77,786 newtons, or that is 77.8 kilo newtons. So the question is to determine the maximum axial force that can be safely applied to the block. Is it this one, P equals 113, or is it this one, P equals 77.8? If we are going to use P equals 113.25, that means it's safe for compressive stress, but it will exceed the shearing stress, because for shearing stress it can only resist up to 77.89. So therefore the maximum P is just 77.8 kilo newtons.